Aloha, dudes. Alright, every time I film this, something goes wrong. Whether it's audio or filming in the wrong settings with the new camera. Anyways, I need negative voltage and positive voltage. I've been playing a lot with OpAmps, and I'm tired of using up all the outputs on my bench power supply, and I don't have a designated dual rail power supply yet. So here's three options. One, the most simple, is the batteries in series, and for all of these I've used green as my 0 volts, or I guess you want to call it ground. Don't really know the right terminology for that, you know, as a muggle I am. So essentially this one right here, let's turn it this way, is just hooked up like this, and the wires are essentially coming off of them just like that with the negative voltage. So for the 9-volt battery we'd have -9, +9, and then the 0 volts. I gotta let the fucking airplane fly by. For the center one here, it's you can kind of look at these like batteries. They're meant for a power supply, so will give you a power supply input and a good range of a DC input, which is why I'm using these. You know, they're easy to put in the project, and each of these are isolated, and we'll scoot in on that in just a second and show you. And then I've got the mains version with the center tap transformer and the rectifiers. But let's do simple first. So this is these are what I got here, and I did a video on making a LiPo charger from these because they're each isolated. I don't remember who I bought them from. I just know they're not super cheap, not really expensive, but it really depends on who you are. I put a lot of money in my lab for a hobby and for someone who doesn't know much. These have a 9 to 30 volt input with a 5 volt 1 amp output, which is perfect for the 4056 little jinglings. So I've got, if I would have just done one, I would have only got 5 volts out, and I knew I wanted more than 5. I prefer 9 and 12, 15 or so. But if I put them in series, again, since they're isolated, it's really easy to do a lot of different things with these. You know, as you parallel this side and for your power, and you series this side. So I've got, if we zoom in, get down there, I've got the positive, negative, the negatives connect this positive, so now these two are in series making 10 volts, and then that negative is my output right there, which is my ground, or 0 volts is what I'm going to call it for now. And then again, the same thing on this side with the positive, negative, positive, negative, and then giving us our negative voltage on this side. So if we actually, I've got 13.5 volts on my bench power supply right now. And I'm going to hook it up to my paralleled end of all these converters. My Fluke 233 will tell us what's going on. So the 0 volt side, we're going to hook pretty much just, I should get a little fucking thing for this. I'll just clip it on for now. So on this side, we're going to get our positive voltage. And there it is, 10.25 volts. And then on our negative side, 10.26 2.5-ish volts, 2.5, 2.6. I mean, it's almost dead nuts the same, which is nice. And that's as simple as that gets. You can series and these together, and you can make a pretty much quite high if you want, because I mean they each supply an amp, so really I can get out of this 10 volts, I can get to half an amp out of each side, which is for the most part more than enough when you're doing the op amps. But the main purpose of setting up the camera was because I built a mains version. We'll zoom right in. I made a mistake on, this. I built this after I laid it out on a circuit board, which is, completely ass backwards if you're new, and I'll show you the mistakes I made. But I had made this to find out where my mistake was. Alright, so here I've got this center tap transformer, and you can see it's a rest in peace Radio Shack, but the center tap transformer was 6.3 volts, 0, 6.3. So really, if you hooked up just the two ends, you would get that 12.6 volts or so or more. And I'll show you that with the meter. And if you hook this up right, you'll get your dual rail power supply. On the input here, you've got your two 6.3 sides based on this. The yellow are the each end, and the black is our center tap. So yellow is both sides of the secondary, black is center tap secondary. And as the voltage comes in, I've got just an indicator LED here. Really, it's just kind of hooked up between this side of the secondary and the center tap, and then I've just used a resistor based on Ohm's law for that 6.3 volts or so. Then the voltage or current, however you want to put it, is going to come. I've got the yellow wire right here. I hope this isn't, that view should be okay. The yellow wire that's coming in this is hooked up to right here, and I've laid this out just like you would see it on a schematic, kind of to help it ease it through. I've got the yellow that comes in to this side. Transformer, really these can go either way. You just need the mains on each end right here. And after that you get a ground out of this side, and your positive out of this side, and then your 0 volts, that green right here, is hooked up to the center tap. That green I have coming down to right here, and then I've got a jumper here attaching the two in connections, pretty much jumping these two capacitors that are in series, just kind of like the batteries, almost exactly like the batteries is what we have right here. Actually, not almost exactly. This is exactly like the setup of the batteries we just showed you. So I've got positive, negative, positive, negative, and then with the center of them being my 0 volts, and then I've got my positive voltage up here, and these are capacitors. These are to keep the power in the circuit for the capacitor. That's what the capacitors are doing. And then the negative down here. So on the output, if you follow this, there's a jumper here, jumps over, and this yellow one's connected into that rail. So this is a positive output. It's going down to the 7805 regulator. And on the 70, this is where the mistake that I had made is the 7805 and the 7905 are not the same connections. So on the 7805, your input is pin 1, and your ground is pin 2, and your output's pin 3. And similarly, but not the same, the 7905 for the negative is ground on pin 1. So you see I got this jump here at an angle, ground on pin 1, V in on pin 2, and V out on pin 3. And then I've got some decoupling caps and more filter caps here. Even though I don't have a load, I think it's good that you just put them there. And I don't know if I need these small ones, since I don't think there's going to be high enough frequencies to need them, but why not? I got them, I put them there. And then these are each going to the output, and I've got a couple connectors here so we can check the voltages. So if I zoom back out, I think that should be good. I get my probes over here. So the one thing that might confuse if I do this is that I've got that ground is hooked up and straight to their pins and to the negative rail on both sides. So really that ground is connected straight across to both rails. So I can hook my lead right here up to just one side for negative or for my ground, and that's everything else I could just tap and probe. So pull the meter in here. Right now I've got nothing on. I'll go flip the variac on. You'll probably watch the indicator LED turn on. Oh, I got my variac cranked all the way down. Go all the way back up here. Flip it on. Alright, so depending on the variance in the voltage, we'll do our DC measurements first. So we would have DC after this point, since everything's sharing the same ground. That ground's essentially connected all the way, all over the place. We would have our unregulated version right here. This would be based on what we're getting out of the transformer after the voltage drops of the diodes, and negative end. I know that the variance right there is a bit different, but I'm not too worried about that at this moment. They're going to be regulated. So then on the output here, after they've gone through this, then you get the regulated. There's the positive and the negative, and they're pretty damn close after they've been regulated, and it's as simple as that. But then now I'll try and bring in my mistake here and do the best I can to show exactly what the mistake was, because it's kind of a little confusing without a schematic. I kind of just laid it out. Alright, so this is a supply I started working on. I guess there's more than one mistake in here, but when I started hooking, I started with just this portion right here with this side coming in off the little center trap transformer here, which is a 9 volt, and then the wires there, the bridge rectifier. I spent a minute just laying it out. Really, if you're doing this, hopefully you have a little bit of creativeness and can figure that out. And they both come up this side and then come to this end where I've got the 7805, 7905, and the 7812 and 7912 regulators, and they're both hooked up in a certain way. Now, I made the mistake thinking the pinouts were the same, so let's try and I'll zoom in a little more, hopefully. So the way this is, let me double check the regulators here. This is where my negative voltage is coming in. So I've got a negative rail on this side, a positive rail on this side. And the negative rail was always fine with the negative coming. This is pin 1, pin 2, pin 3. So the negative was coming into pin 1 right here. Then the input was coming into pin 2. And then the output of 3 going down, which is going the ground. That's my 7812 straight down, but it's also coming into pin 2 of this regulator here, with sharing there's a ground in the middle, and then out being my 7812 and my negative 5 volts right here. On this side, thinking it was the same, was running my input into pin 1, which was, you could see where it was coming in and coming straight across, which is wrong. And pretty much I'd switched the first 2 pins. So the voltage was, I had a big voltage drop. It wasn't, I had a big voltage drop on the negative side, but this side wasn't working. So once I built on the breadboard and figured it out, it was pretty easy to find a mistake. And I just kind of unsoldered and moved the soldering around, which now it works fine. And I've got my 4 rails and my ground. Second mistake that I had made was with the switches. So I'm wiring these switches up and I'm like, okay, I hooked my ground up to both sides because I was going to use ground as my switch. That's not really a good idea because then you still have between positive and negative 5 volts. You have that or 24 volts depending on which one you're on. So I was like, okay, I really need to hook up the positive and negative voltage to the switch. But I can't just hook up one because then you get the other still. So I had to stop completely what I was doing and order some double pole switches. That way I can actually switch each of the voltages on and off. And other than that, everything seems to work. Sorry if you want a schematic. I'm not really going to go through the schematic I used to make this. Just be creative and figure it out. It's not really, if I can figure it out, most people, if you're watching a video on these, making a dual rail supply, hopefully you can figure out how to make one of these. If not, then I'm sorry, but there's tons of schematics for little power supplies that are a lot more clean than this on the internet. But just for fun, let's plug this cocksucker in. And just as before, I've got a green ground right here. If the switch is down, I've got them both connected on the top of the switch here, so I'm just going to connect to that. And then I should get all my voltages out of these 2 points right here. I've got which ones are which marked on here, 5 and 12. Try and keep these all far enough apart. So let me flip the power on, hopefully nothing pops. So far, we're good. So let's check the negative 5. And there's my negative 5, positive 5, and negative 12, and my positive 12. And that should be enough for me to test and learn and play with more shit. But that's how you do it if you want to make it. It's not too hard. Especially if you're at the level where you want to make it and, you know, for experimenting. But that's probably the last you'll see of this until, of this little power supply, until it's done and it ends up in another video with OpAmps or something. But for now, fuck off. Mahalo for watching.